class. In today's video, we're going to be looking at factorizing quadratic expressions. The learning intention of this video is we're going to understand what it means to write an expression in factorized form. We're going to know how to always look for a common factor before we even attempt other factorizing techniques. We're going to recognize a difference of perfect squares, including ones involving surds. We're going to factorize using a common factor or a difference of perfect squares. And lastly, we're going to use the grouping technique to factorize as well. Now, the very first thing that I want to talk about is what is factorizing. Now, factorizing is the opposite process of expanding, okay? So from expanding, what you generally do is you multiply to make things larger, okay? Factorizing is the opposite process of that, and it involves trying to actually express things as a product of factors. So in this case over here, 2 is a factor and x plus 1 is a factor, and you're rewriting this as a product, okay? Because as you can see, this is multiplying it together. Now, what you need to know is that there are many different types of ways that you could actually factorize algebraic expressions, but you need to be aware that each factorizing technique can only be used under certain circumstances. And we're going to go through some of these in today's lesson. We're going to go through the first 3, and for the other ones, they're going to need their own dedicated lessons because it is a bit more tricky, okay? So the first one is about factorizing by finding the highest common factor. We said that the highest common factor is the highest term that can be divisible by all terms of the expression. So I've got the steps outlined over here. What you want to do is you want to identify the highest common factor, then place that number or term found outside of the brackets, and then divide the rest of the terms in the expression by the highest common factor. So if in our first example, 3x plus 9, the highest common factor is going to be 3. This 3 is going to be placed outside of the bracket. So it's going to be something like 3 bracket and something inside over here, inside the brackets. To find out what this is going to be, you need to therefore divide this expression over here by 3. And if you did this, this is going to be your answer. Similarly, for the next example, find out your highest common factor. This is going to be x, and therefore your final answer is going to be x bracket x plus 7. You achieve this by dividing each of these terms by x, which is the highest common factor, okay? Now, many students often make a common mistake when they're factorizing by finding the highest common factor. They generally find a factor, but it's not necessarily the highest common factor. And I'll show you what I mean by this. So one of the ways that students could factorize is that they've identified that 5 is a factor of both 15x as well as 20x squared. This is correct though, and if you did this, this is the answer that students would attain, okay? Now, although this is partially correct, okay, when we're trying to factorize, we want to find the highest common factor. So you need to factorize further. Alternatively, another way that a student could factorize this is that they can see that x is a factor for both of these terms, so they might put x outside the bracket. However, as you can see, there's a common factor within present the actual bracket itself, so therefore 5 can go into both 15 and 20x, so therefore this could be further simplified. So I always want to remind you guys that you need to ensure you review your answers so that there are no common factors present, and if you continue to factorize, then this should be the answer that you obtain. What I want you to do as a quick warm-up of today's lesson, I want you to spend the first 10 minutes answering as much questions as you can from questions 2, okay? So have a go with answering these questions, and then we'll move to the next part of today's lesson. What we're going to be looking at now is how do we actually factorize expressions that contain a common binomial factor. Now, we previously talked about what a binomial factor was in our last lesson, and we said a binomial factor is essentially a factor that consists of 2 terms, okay? So let's use this example of here so that we have a better understanding. You've got 5x minus 1, and then you've got ax minus 1. Now, notice in this case over here, there is a common factor that's present in each of these 2 terms. That's one term. That's another term. We can clearly say that x minus 1 is the factor, and we refer to this factor as a binomial since it contains 2 terms, okay? So if I rewrite it like this, you can clearly say that x minus 1 over here is going to be the binomial factor. Now, in this example over here, I'm going to show you a very long way of how do we actually factorize this, and this is going to make sense if you're a beginner, okay? So what I'm going to do is I'm going to state that z is equal to x minus 1, meaning z is equal to my binomial factor. Now, I could have chosen any other letter, just as I've just decided to choose z in this case. You could make it as a, not a since a is already here, but you could make it as b, c, d, doesn't matter at all. And once you've defined this, what I want you to do is I want you to replace x minus 1 as z. And this is going to make things a lot more simpler and a lot more easier for you to interpret, okay? So if I rewrite my expression as this, it's going to be 5z minus az, okay? I've just replaced x minus 1 with z. Once I've done this, we can clearly factorize the expression once it's in this form, okay? We can see that z is the highest common factor, so I'll take z outside, and if I do this, my answer is going to be z bracket 5 minus a. We've already stated that z is equal to x minus 1, so what we'll do now is wherever I see z, I want to replace that with x minus 1, so therefore my final answer is going to be x minus 1 bracket 5 minus a. All I did was just replace it back in again, and this is going to be my final answer, okay? I want to go through another example, okay, guys? So again, do the exact same process. In this case over here, we can clearly see that the binomial factor is going to be x plus 2. I'll replace the expression with z, so it's going to be bz plus 3z. I can now easily factorize it in this form. So z is the highest factor, so take it outside. And now sub it in, so you can get your final answer, which is going to be x plus 2 bracket b plus 3. Now, what I want you to do, class, is I want you to have a go at answering this question here. Give yourself 2 minutes and then compare your answers with my answers. If you guys have done this successfully, then this over here is the solution that you should obtain. You should have got x plus 2, 3 minus a. What I want you to do right now is I want you to have a bit more practice of answering these questions over here. It shouldn't take you 10 minutes. It should take you maybe even 5 minutes. Have a go for answering question 3 and then move on to the next part of today's video. What we're going to be looking at now is how do we actually factorize differences of perfect squares, okay? This is a different method to factorize quadratic expressions, and when we use this method, we need to ensure that the expression contains only 2 terms and needs to closely resemble a difference of perfect square, okay? So I just want to remind you that this over here was the general formula of DOPS, okay? So you've got 2 perfect squares that's separated by a takeaway sign, okay? And when you've got this, you can kind of rewrite this in this particular format over here. Now, on the right-hand side, I've got the steps that you could actually follow to actually factorize DOPS, okay? What we need to do is we need to identify the values of both a as well as b by finding the square roots of each perfect square. And once we've done that, all we need to do is just substitute values in this particular factorized form. So let's look at an example of how we could do this, okay? So I've got an example, 81 minus 9x squared, okay? Now in this case, this closely resembles a dot because you've got one perfect square here, you've got another perfect square here that's separated by a takeaway sign. Now what I'll do is I'll find the values of a and b. So how do we do that? Well, remember, this is the formula of a dot over here, okay? We know that a squared in this case is equal to 81. So in order to find out the value of just a, we just need to do the opposite of a square, which is going to be the square root. So find out what is the square root of 81, which is going to be 9. And so we do this exact same process to find out what b is going to be. So b squared is equal to 9x squared. So in this case over here, b is going to equal to 3x. Once I've found out the answers for both a and b, I'll just substitute it back into this factorized form over here. So therefore, if I do this, my answer is going to be 9 plus 3x bracket 9 minus 3x, okay? Alternatively, as I said from last lesson, you could also rewrite it like this. The order does not matter at all. What I want you to do right now is I want you to have an attempt at answering both of these questions and then compare your answers to my answers after 5 minutes. If you guys have done it successfully, this is going to be the solutions over here. So for the first one, the value of a is going to equal to 10. B is going to equal to 5z. So therefore, this is going to be the answer for the first one. And for the second question, a is going to equal to 7w. B is going to equal to 4z squared. That should be a z there, not an x. And therefore, this is going to be your answer. And that should, again, be a z, not an x. Now, I'm going to look at another closely related example, okay? And in these kinds of examples over here, you don't really have a perfect square for one of them, but you can still kind of make it as a perfect square if you express it as a surd, okay? So in this case over here, we'll do the exact same process again. So we know that a squared is equal to x squared, therefore a is going to be x. That's relatively easy. In this case over here, you know that 5 is not a perfect square at all. So therefore, if you were to find out what is the square root of 5, it's just going to be square root of 5. There's no nice whole number. So we'll leave it in its exact form by leaving it as a surd. So therefore, if you were to find out the answer, again, do the exact same thing where you substitute the values, and this is going to be your answer. In these examples, when you don't happen to have a perfect square at all, you just have to include the square root surd sign. What I'd like you to do right now for the next 20 minutes is I'd like you to please answer questions 4, 5, as well as 6. Please take your time with answering these questions, and after you do this, please move on to the next part of today's lesson. We're going to be looking at the last part of today's lesson, which is about factorizing by grouping, okay? So factorizing by grouping is a certain type of factorizing technique that can only be used when the quadratic expression only contains 4 terms, okay? The second requirement is that the first 2 terms has a common factor and that the last 2 terms also has another common factor, okay? So as you can see over here, what you want to do is you want to find a factor that's present in x squared and 5x and find another factor present in 2x minus 10, okay? In this case over here, we know that x can go to x squared plus 5x, and we know that 2 can go into both 2x as well as 10. So if I was to factorize it, this is what it would look like, and I've combined it together. Now, once I've combined it together, can you see that there's a binomial factor that's present in this particular expression? Notice that both of these terms over here, okay, so that's one term, that's another term, they both have x plus 5 as a factor. So what I could do is I could take that outside and therefore factorize it. So therefore, if I was to factorize it, this would actually be my answer over here, okay? So again, this is pretty much using the exact same thing that we looked at before, about expressions containing a common binomial factor and putting it into just a slightly different context, okay? So please copy this example down so therefore you can answer this question over here. So give yourself 2 minutes or so and therefore compare your answers with my answers. If you guys have done it successfully, what you would need to do again is just factorize the first 2 terms and the last 2 terms. In this case over here, the common factor in the first 2 terms is going to be x. The common factor present in the last 2 terms is going to be a. Now, notice again that there's a common binomial factor, so take that outside, and therefore if you factorize it, it's going to be this as your final answer. What I'd like you to do right now, guys, is I want you to answer question 7. Question 7 is related to factorizing by grouping, but question 10 is going to be a mix. It's going to be using all the different types of factorizing techniques that we've already looked at in today's lesson. This is going to be a summary. All right, just to conclude today's lesson, I'm just going to quickly provide a quick summary. We looked at factorization, what it is. It involves putting 2 factors as a product of one another, and there are different ways of which we could actually factorize quadratic expressions, okay? We looked at the first 3 methods already, finding the highest common factor. DOPS was used only when there was only 2 terms, okay? And they needed to have like perfect squares or ish. It needs to kind of resemble that, whereas the grouping method only worked when there were only 4 terms, okay? So make sure you include this little flow chart and summary into your actual notes. This is the end of today's video. Hopefully you should be able to address all of the success criteria in today's lesson. Thank you for watching today's video. I'll see you guys again in the next video. Bye.